Evaluate the limit using L'Hopital's rule. Here we have the limit as x goes to infinity of 2x squared divided by e to the 10x. So, L'Hopital's rule only applies in certain situations. The most common places that you'll see it are when you have a limit that evaluates to either 0 over 0 or infinity over infinity. So let's see what kind we might have here. So if I were to hypothetically allow x to get larger and larger, then what's going to happen with 2x squared is it's also going to get larger and larger. You can think of plugging in infinity, but I don't really like that idea because it's clearly not a number, but the idea is it would just continue to get large. Same thing happens with the exponential function e to some power x. As x gets larger and larger, the y values also get larger and larger. So we have something of the form infinity over infinity, which means we can apply L'Hopital's rule. And L'Hopital's rule is fairly easy to apply. What we do is, first, it's good to document that that's what you did. And a common way of doing that is just saying equals with an L apostrophe H over top that equals. So this is equal to the limit through L'Hopital's rule as x goes to infinity. And we do the derivative of the numerator, which would be 4x, over the derivative of the denominator. And e to the 10x, its derivative would be 10e to the 10x. And if you're unsure how either of those derivatives are developed, then you need to review some differentiation. Next, here, now if we plug in infinity again and allow things to grow, this is a linear function. Well, linear functions, as we let x go to infinity, also go to infinity. Same thing for exponentials. So it's still of the type infinity over infinity, which means we can apply L'Hopital's rule again. And there's no limit to how many times you can apply L'Hopital's rule. You just keep doing it until you get a result. So here, taking the derivatives of the numerator and denominator separately, I would now have 4 over 10e to the 10x. All right, now, as I let x go to infinity, this is no longer changing. It's the constant value 4. But this thing is growing without bound. So I'm kind of in this form of 4 divided by infinity, which again doesn't really make a whole lot of sense. But the idea is the denominator is growing without bound. The numerator is staying the same. What's going to happen to the value of this fraction is it's going to be pulled to 0.